Hello, everyone. Welcome to the second video lecture of our second lecture, which is about cyber attacks. If you remember, we started talking about uh, major types of malwares in computer systems, and I have introduced 5 of them to you, including viruses, worms, and then Trojans, bots, and APTs. Okay, we started talking about viruses, and I said viruses are in fact piece of code that are being inserted or are being added into another program, and once that program starts execution, the virus starts propagating and start infecting the system or implement the payload or the malicious activity that the virus is developed to doing that. And also we ended up here that I showed you sample microvirus, which is a virus that is being as a micro function, which is being added to Microsoft Word and Outlook, named as Militia. This microvirus, we talked about it. I said that it is actually a part of it is a part of a kind of microvirus that it performs some actions. It tries to infect the template, the Microsoft template Word of that kind of target system, or if the template is previously infected, it tries to infect the current document, whatever the current document is. And then if this is the first time that this microvirus is infecting the system, it sends the same virus through some attachment to 50 of the percent in your address book, in the address book of the kind of victim system. So it in fact seeks vulnerability in both Microsoft Word plus Outlook, and propagates itself through sending emails to 50 of persons in your contact. And it just sends it one time, not many times, because of course it's going to be very many number of emails, and you quickly understand it, you quickly detect it. So to understand that, it defines a registry key under Windows registry. You know what is Windows registry? Is a place that Windows keeps track of everything, applications, their status, and so on. And it defines a registry key called militia. And if the militia key is there, is already defined in registry, so it doesn't send it. So it sends only for the first time. Anyway, and now let's continue with our discussion. We talked about microviruses, which are scripting viruses, and I said that they can be saved with a document, with a specific document, a user document, or they can be saved in a template, in a global template, like, for example, Microsoft Word template or Microsoft Excel worksheet template, like what we saw in the militia. And also in terms of start or triggering a microvirus like militia, they can start whenever that specific application starts. For example, when Word starts, or whenever the specific document or any document is open, or whenever a new document is created, or whenever a document is closed. So whatever actions we have access to when we are writing micro in Microsoft Word or Microsoft Excel or any type of other applications, all of those applications, this is again something that we have talked about it, and I said this before, that the virus, including microviruses, they do have access to all functionalities and capabilities that the hosting application has access to them. So since the Microsoft Word, for example, can open a file, can create a file, can save a file, all of these functionalities, all of these privileges are in fact somehow will be inherited by the microvirus, and they can do the same thing. So that's why we say whatever the host application can do, the microvirus also is capable of doing them. and that makes them somehow difficult, or gives them actually a wide variety of capabilities that can be used to attack our computers. Okay, and now let's get some classification for viruses. We've talked about the viruses and how they work, their different phases they have, and also we've talked about the microviruses. But now we want to talk. I'm going to give you two classifications for viruses. The first classification is based on the target of a virus. Okay, when a virus gets started to implement its payload, to implement the malicious activity which is written to do, which is developed to do, what is that specific malicious activity? What type of resources in a computer system can be infected or can be destroyed? Here are a list of them, the most important one. A virus can target attacking the boot sector. We call them as a boot sector infector viruses. Okay, what is a boot sector? Some of you may not know what is a boot sector. A boot sector, this is actually a kind of abstract image of a disk. Once you have a disk, you have a disk and you have multiple drives on your disk. At the very start of every drive that you have, for example, drive C, drive D, whatever, and it doesn't matter if the disk is an actual drive, like, for example, traditional hard disk drive, or if it's, for example, electronic version like SSDs, that they don't have the physical drive, they don't have a rotating disks. But in either case, the very first portion of every drive is called a boot record. So we have a boot record, this brown one. We have a boot record for drive C. We have another boot record for drive D that they store some information, some basic information about that drive, including the file system and stuff like that. But there is one special record which is called master boot record. And that master boot record is for the whole disk, not only for drive C or drive D. That serves the whole disk. And that sector contains some information which is being used by the operating system right after reset. Right after you reset, there is no meaningful information in your RAM, in the main memory. So the processor jumps to ROM, as we mentioned in the lecture 0, and runs some instruction from the ROM. Those instructions point to here, to the master boot record, this green one. And this master boot record contains a part of information, a very small program which is called loader. And the loader starts loading the operating system from the places that operating system has been previously saved into the main memory, which is the RAM. So this way you see that the operating system is being loaded from the disk to the RAM for getting the system prepared for user activity. So with this kind of quick introduction about MBR or master boot record, now it's clear for you that how important the master boot record is. If someone changes a master boot record, you cannot restart your computer, or if you restart it, you cannot boot it again, because the information, the required information for getting the system booted up is not here. So some viruses infect the master boot record or MBR. Some other viruses just come and simply infect some files. They might be some normal files, user files, or operating system files, or any executable file. These are called file infector viruses. We have microviruses that we talked about them, and they kind of infect some user files, and in order to have it propagated and run, of course, that file should be some file that user is allowed to write macros for them, like files that we can create in Microsoft kind of Office suite, like Microsoft Word, Microsoft Excel, and others. And of course, a virus might be multi-part. It means that it can infect multiple of these things together, which of course makes it more severe. Okay, But there is another classification for viruses, which refers to the concealment strategy of the virus. Of course, when a hacker develops a virus, he or she doesn't want the virus to be detected right away or in the first trial. They want to, or they try to keep the virus as hidden as possible, because that gives the virus enough time for propagation and for infecting more and more systems. So there are some concealment strategies used by virus developers that they take it in order to keep the virus hidden as long as possible. What are those strategies? I've listed them here. The first one is encrypted virus. A virus, encrypted viruses are actually trying to find some random encryption keys, and then they encrypt the virus using that encryption key. So it means that once the virus is infected some of the files, and now the code of the virus is not just like a normal code in a text file or in a that you can find it, because it was encrypted after infection. So this is one way that virus developers or hackers try to keep their viruses hidden. The second strategy is stealth virus, which is a form of virus that explicitly designed to hide itself or kind of prevent from being detected by the antiviruses. It means that there are some active actions or active plans in the virus development that tries to keep the virus hidden. It means that, for example, it's not, it's the actions, the way different is different with the encryption is that it's not one single plan, and the plan may differ based on the activities of the, for example, antivirus software. Okay, we have polymorphic viruses that they're kind of smart. They try to mutate every time after one infection and before propagation. Once they infect the system, they mutate. It means that the version that has infected the current system is not identical to the version which is going to be propagated. So once a computer system is infected, the virus works on itself and tries some part of its code, and then sends something else to a different computer or a different file. So the versions of the virus are not identical. And a more advanced version is metamorphic viruses, that it's one step further than polymorphism. They try to even change the behavior of the virus. So they don't let the virus to show one single pattern in its behavior, because the reason you see these level of changes is that, of course, hackers started to develop viruses, just simple viruses, and then antivirus developers, they use some type of signature to easily catch those. And they said, okay, we encrypt the virus. And then they also could be easily detected, because whenever you see an encrypted code in a part of an executable file, it means that most probably it's something malicious. So it might be. So they try to avoid encryption. They try to apply polymorphism. They try to change the code every time. So that's why you see that different levels of tries or efforts have been put here in order to change the shape, change the appearance, and at the last level, change even the behavior of a virus in order to make it more difficult for detection from by an antivirus software application. So, and the last one, like I said, it's not even the code, but also the behavior. It tries to mutate and also completely change the behavior of the virus in order to make it even more difficult for an antivirus software to detect that virus. Okay, we are done with viruses. The next malware that we'll be talking about are worms. Worms, again, I'll be giving you a general description about worms. And then later we go to details and we see the phases of worms and replication and many other details about worms. But let's get started and define the worms. Worms are, like we mentioned in the introduction part, the way worms are different than viruses is worms are independent programs and they don't need any host application to attach to. So worms are programs that actively seeks out more machines to infect. So when we say actively seeks out, it means that they search by themselves. They don't need any hosting application. They don't need to be attached to an executable file, or they don't need to be attached as a macro to some user file. There are single or maybe separate files that actively search to find vulnerabilities and exploit the vulnerabilities in order to either propagate or kind of damage the system. And each infected machine, each infected computer itself serves a launching platform for the worm. The major feature is that they exploit software vulnerabilities and sometimes even network vulnerabilities. Again, this is another point that worms are different than viruses. In fact, if we want to give some levelization, I would say worms are more dangerous than viruses, because viruses are defined or are developed in order to attack one specific vulnerability and use one specific vulnerability, or maybe multiple. But worms, the way worms work, they seek for different vulnerabilities. They check the first one: is it available? Is this vulnerability exploitable on this system? Okay, no, go to the next one, go to the next one. And they try many different software and network vulnerabilities in order to finally they find something. Of course, they can check numerous, or let's say infinite number of vulnerabilities. That's impossible because at the end of the day, viruses or worms are again, they are a piece of code. So I'm a programmer and I'm going to write a code. How many lines I can write in order to find vulnerabilities? That's of course something limited. So they can search for infinite number of vulnerabilities, but the way they search is way more wider and vaster than viruses. Viruses target some specific vulnerability and try to use it, but worms try to find something. And and like I said, they try to search or find vulnerabilities and exploit vulnerabilities in the applications that might be user application or server application. Client application or client program versus server program. It means this refers to when we are talking about the network system. If the application is run in my side as a client, as a user, or at the server side, they don't care. They search both, and if they find something, they'll use it. For propagation or for for the malicious activity or for the payload. And these type of vulnerabilities include all of these. It might be network connections. They check different network connections to find any open thing or any vulnerable point. They may spread through shared media, like any type of shared drives or shared devices, USBs, CDs, DVDs, and even worms. They can use emails as a carrier, as a platform, in order to get propagated. So sometimes we see that worms, they have microviruses next to them that help them to get propagated. And upon activation, of course, they try to replicate themselves and propagate, and also infect and also kind of damage the infected system. And this is the first worm ever developed in 1980s by Xerox Palo Alto Lab. And it was a non-malicious worm, just seeking for finding idle systems in order to run a heavily computation intensive task, which actually makes sense now by the explanation I gave you the other day about cryptographic currencies or cryptocurrencies. This might be again another raise in the developing worms. Okay, let's now talk about details of how worms might be replicated, the exact ways that worms might be replicated. There are 5 ways that we list for the worms for replication or propagation. Replication here, in fact, it means propagation. They may get propagated through electronic emails or instant message. They can copy themselves as an email or just send it to someone else, or as a file attachment in instant messaging services. There are many of them, you know. File sharing is another way that worms can use as a way in order to get propagated. They create a copy of itself and put it on a removable media. Remote execution capability. This is something that some operating system, or let's say most of modern operating systems, allow that. You can execute some application while you are not back of your computer. You need to, of course, set up some settings, but after that, if you set it up, you can log into your computer through network from a distance location. You are not on back of your computer, you are somewhere else, but you still have the capability to log in and run something and execute something. Okay, worm check if that service is enabled in your system. They try to do the same thing. They copy themselves and send it to a kind of destination or target system and try to run the worm on that machine as well. So you are here, the worm kind of tries to look at different users and reach them over the network and start doing remote execution. Of course, you may say how a worm try to find different destinations. Is it going to be randomly or blindly, or does the worm has decide based on some information? I'll talk about this in few slides later, and I'll tell you that they can do it randomly or blindly, or they may do it in a more smart way. Okay, again, another way for propagation of worms is through remote file access or file transfer. Again, this is a service that most of operating systems offer that. You can transfer files while you are not back of your computer. You can log in again remotely and transfer files. This is most of the time we see it as the same thing. For example, you do remote access into your Windows machine, and you can run things or you can transfer files. We see them as a single application, but in fact, they use different protocols for file transfer or for execution. Either file transfer or execution, I mean remote file transfer or remote file execution, of course, they can be used by worms to copy themselves and propagate. And then remote login itself, which uses a different protocol, they also can be used by worms in order to log into the system and send a copy of themselves to the target machine. So we have and like I said, worms are not like viruses that just stand still and wait until someone copies some file from somewhere to somewhere or emails something. No, they just scan all of these kind of approaches or all of these ways and find one and try to propagate. Okay, worm phases. What are the general steps or phases that we see in a life cycle of a worm? Basically, the cycles are similar to what we've seen in viruses. We have a dormant phase at which a worm has already infected the system, but it's not doing it. It's doing nothing, or it's just waiting for some situation. That's called dormant. And then we have propagation, that worm tries to propagate to other systems and infect more and more systems. And then we have triggering. Some logic bump may happen, or some specific event, or a combination of some events may happen, and then worm triggers And then as the final execution or implementation of the malicious activity or trying to damage the system. Or in another word, execution is a time that worm tries to violate security policies or security regulation that we have in our system. So phases, like I said, are similar to what we have or what we see in viruses. But of course, this propagation phase is more active. It's not like viruses that they just wait for user to do something. For example, in the case of militia virus that we talked about, if you don't open any Microsoft Word document, or just don't open your Microsoft Word at all, that virus will not be propagated at all. But that's not the case for worms. The propagation phase for worms, that includes more activity from the worm, and worm, like I said, it scans different vulnerabilities, it checks different vulnerabilities, and tries to find appropriate access mechanism in order to get propagated. These are a list of vulnerabilities or exploits that the worm may use. Table of host or host tables, address books that you have in your email or whatever portion of your computer, trusted peers, who are the trusted peers over the network, remote system access addresses, removable media devices, and many other things. We'll be talking about a feature of modern modern worms, and I'll be saying that I have listed, of course, a few of them here, but this list is infinite, in fact, because, like I said, one feature of modern or state-of-the-art worms is that they should be seeking for vulnerabilities that no one is aware of them. If there is a vulnerability that is well documented, everybody knows that. So of course, operating system developers, let's say Microsoft, they kind of release some patches in order to fix it. So this list is in fact some examples of vulnerabilities which have been already used in some worms, but of course it is endless list, and newer worms try to find other or newer vulnerabilities. Anyway, the scanning phase is one of the important phases in worm, because they scan, they search to find mechanisms to get propagated, and then in this second part of the propagation, of course, they use the found vulnerability or found access mechanism in order to get really propagated. So this is finding way for propagation, and this is the implementation of the propagation. And of course, like I said, many worms they check if the worm has, the system has already or has previously infected or not, because you don't want to infect one system multiple times, and because that makes it easier for detection. And that may happen to writing on Windows registry or defining the specific system process. Some of them, they define a specific system process that every time that you restart the system, that process starts. It's doing nothing, but it's there just like a flag in order to let the worm know that, okay, this system is already infected. I'm not gonna infect it anymore. This system has already infected. So now I'm just going to propagate as more as I can. Okay, I'm going to concentrate on this part, scanning for finding appropriate mechanisms. How really a worm can try or can examine different ways of finding or exploiting access mechanism for propagation. That might be a random search. For example, in a network situation, each compromised host or machine probes random IP address. It means that it sends information to random IP addresses in order to try to get them infected. Of course, this is somehow a blind way, and it has both at the same time negative and positive points. I mean, from the hacker's point of view, I'm talking from the hacker's point of view. The negative point is that since the worm propagation is random and worm is just sending to some random host, it can be detected easy. And the positive point from the hacker's point of view is that it generates some huge traffic over the network, and most of the time it downs the network for some hours or maybe some days. So the worm here at this stage is not even triggered, but the propagation itself make a problem for the network. So you see, even the propagation might be might have some negative impact. So that performance degradation in the network might be a plus or positive point from the hacker's point of view, but at the same time, it makes it easy for detection. Okay, and a smarter way to propagate worm is through hit list. It means that the worm developer, it just doesn't let the worm to randomly propagate to some random destination. No, the worm developer first tries to come up with a list of potential potential vulnerable machines. It puts the addresses together and make a long list. Of course, making that list is not easy. It may take time, and this makes the development of the worm it may make it longer in terms of time, and it needs effort, and it may cost even to the worm developer. But after that list is exploited, if after that list is crafted by the worm developer can share a part of that list of potentially vulnerable machines to the infected machines, so that each infected machine can use a part of that, a portion of that list, in order to scan and in order to get propagated. So this way, this is of course a more smart way. And it tries to keep the propagation phase hidden. It tries to prevent or reduce the chance of software patches or security engineers to detect the worm in the propagation phase. So the result is that the propagation will be very short. It doesn't have a long scanning period, because the worm developer somehow gives the worm an effective list of potential vulnerable machines, and so the scanning would be very short and very effective at the same time. And of course, like I said, it makes it difficult. It makes worm detection more difficult, because now it's not just, it doesn't have any footprint. We cannot detect that, okay, some attack is undergo. Another way for scanning and finding vulnerabilities is topological information. The worm looks at topological information of the system that it is on, the already infected system, and try to use that topological information to find more hosts or more computers based on that topological information. For example, it looks at the network topology. Who are the neighboring hosts? Is that easy to access them or not? And based on that information, again, worm tries to scan and find vulnerabilities, and it's not, again, a blind way. Of course, this is not as effective as the previous one, hit list. It is more, it relies more on the worm itself, not the worm developer. And there are more or higher chance here for a worm to be detected, but this one is also better than that random one. And then local subnet. Local subnet is the easiest way, which means that the worm seeks finding access mechanism or vulnerabilities in the over the machines or computers which are in the same network as the infected machine. I have a computer. That computer is infected by a worm. The worm tries to find ways to attach other computers in my subnetwork. For example, I'm on the campus. I'm using ANT's internet, but my computer is infected by a worm. Of course, the worm is better first try to access other computers in the same network, I mean in the ANT's network. Why? Because the worm in that case doesn't need to go beyond the firewall. If you want to go, if you want to connect other networks which are not in your local network, if you want to go access some machines out of the ANT's network, of course you need to pass the ANT's firewall. And ANT's firewall is not easy. They of course have many things. So one way that worm developers they take it is that they try to first find kind of potential vulnerable machines in the local network that they are in. And of course, this is easier, but the shortcoming is that, of course, it kind of limits the infection range of or infection proximity of the worm. So, of course, they don't only use this. They try to first use this type of scanning for propagation. And once they're propagated all in the computers or host in your local network, they try to do it from that point to machines out of the local network. But these are scanning methods that the worm may use in order to find kind of targets or discover targets for kind of for the propagation phase of a worm. And as you see, it is very more active than what we have seen in the viruses. We don't have such thing in viruses. Viruses just sit there and waits for the user to do something, but worms are not like that. They do they do their trial in order to find or discover target machines for kind of for propagation. Okay, now let's talk about the propagation model. There is a model for the propagation of worms and viruses somehow, which is actually being somehow inspired from the real viruses in kind of medical viruses, the way they propagate in the environment. And they applied it on viruses and worms in computer security, and they realized that, okay, this has a good accuracy and it's close enough, we can use it. The model says that a worm or a virus propagation rate kind of follows something like this: fraction of infected hosts. At the very start, there are a zero or maybe a very few number of hosts or computers which are infected. And then there is one phase at which it says a slow start phase. Slow start is very slow, but it grows exponentially. At this slow start phase that I called it phase one, the number of infected hosts or the number of infected computers, it increases exponentially. And of course, this exponential growth helps the worm or virus to get spread very quickly, and a significant fraction of the community will be infected by the malware, which might be the worm or virus, very quickly. For understanding, when we say exponential, consider this. Consider a situation at which every infected computer infects two more machines, or worm try to get propagated from every infected computer to two more machines, not more. So the number of infected machines will be something like this: 1, 2, 4, 8, and then 2 to the power of 10, 2 to the power of 100. After 100 trials, after a period of 100 cycles 2 to the power of 100, which is a super big number. So it grows exponentially. In the phase 2, which is also called here fast spread phase, the spread rate gets close to linear. Why? The reason is here for some of the machines, the spread has already done and they are not contributing in more spread. There are some of the infected machines, they are into their next phases of the worm cycle or virus cycle. They try to start trigger, or they're in the kind of payload part or the payload phase. They're trying to really damage their systems. So some of them do not contribute in the propagation. So the propagation rate gets close to linear in the second phase. And after the second phase, that the propagation rate gets close to linear, we have the third phase at which the propagation here is even less than linear. Why? Because there are not much systems for propagation. Most of the systems that could be found for propagation have already found and are already infected by the worm or virus. So there are a few systems left. Look here in our XSY, it shows the fraction. The percentage of the infected systems, ideally, we like to say that it gets to 100%. But of course, some of the systems may have, let's say, high security equipment or high security settings, so it might not be easy to infect all 100% machines available to the worm or to the virus. So at the last phase or phase 3, which is called slow finish phase, finding more machines or more devices or more computers to infect them, it becomes difficult and difficult, and difficulty grows, so the rate of infection decreases. And of course, you know, the ideal thing from security standpoint for detecting the worm or virus is that we would like to detect the worm in the very earliest stages of the slow start phase. Because if the slow start phase finishes, a good number of our systems has already infected, something like 40% of our computer. And then if a 40% of your computer in your, or devices in your network or in your organization, they're already infected, it is not gonna be easy to kind of stop the propagation. It definitely goes to higher percentage, like 78. So the ideal goal from security point of view is to stop or detect a worm at the very earliest stage of phase 1. Okay, let's talk about the attendance code for today. Please use this name, Verzov, the way which is written here as an attendance code for today's class. So the attendance code for today's class is Verzov, as you see here, with capital W. Okay, here in this table, you see a list of recent worms attack. Militia is also here because it is, like I said, it's a part of the militia is a microvirus that infect the Word document, but another part of that is a worm because it seeks also vulnerabilities in Outlook and spread the infected document or file to other machines through sending emails. So overall, we call the militia, we see the militia as a worm that has a kind of microvirus in itself in order to infect local files in the local computer. And here are the list of recent. You can look at each. You can go online and search for them. Some of them are interesting. Okay, and now I'm going to talk about one example worm, which is called WannaCry. This is one recent worm which kind of deployed in May 2017. It spread extremely fast over a period of hours to days, and it used to infect computers over 150 different countries. It was a worm, and that worm was trying to do a ransomware. Ransomware means that some malware, it might be virus, worm, or whatever, they do something and then they ask for money. They ask for money. They force the owner of the computer system, the infected system, or the victim system to pay some money in order to, for example, release the resource or release the files or whatever. The way this one works is this, and it comes and encrypts your file on your computer so that you don't have access to your local files. And of course, it shows something like this. It says that your files are infected. If you want them decrypted, pay us something. And they used to ask some money in Bitcoin, cryptocurrency, which is more difficult to be tracked. And they could, based on the numbers I found on web, they could collect something about $150,000 from something about 300 different users that they tried to pay them. But they, even after paying, reports show that even after paying, they couldn't get access to their files. And the way kind of research community addressed or defeated against this worm was actually interesting, that I'm going to talk about it. Yeah, one researcher called Marcus Hutchins in the UK, he found a kill switch in the code of the worm. The worm used to there is a kind of if then else statement in the code of the worm. It checks for some domain online on internet, and if that domain is not available, the worm, if that connection is not being made, the worm says that the domain is not there, so let's encrypt the file and ask for the money. And the domain was something dummy, which is not on internet. So the worm never the developer asked for something. Let's say, for example, if you can get connected to, let's say, 123.123abc.com, and there is no such site, there is no such domain on internet, so the worm can never ever get connected to that, and always it says it kind of returns no, failed connection, and after that it starts encrypting the file. This researcher said, okay, it should be easy. We go and we register a domain like what worm is seeking for. They went online, they registered a domain with the same name that the worm was seeking for, and after that, the worm kind of realized that, okay, I find this domain, I can get connected, and then there is no encryption. So they somehow trick the worm code this way. And that's called a kill switch domain. If that domain is there, do nothing. If that domain is not, you cannot get connected to that domain, encrypt the file. And the researcher used this in order to defeat the system. Of course, those computers that they kind of got stuck with the worm and their files were encrypted, they couldn't benefit from this technique, from this defense. But it prevented, the technique prevented the worm from more spread, from more propagation. Okay, I'm going to talk about some features that we see in the state-of-the-art worms. Of course, we defined worms, but some features are interesting to see that modern worms are getting more complicated. The first thing is multi-platform. Uh, Traditionally, worms were developed for only a single platform, for example, for Windows machine. But now worm developers, they're considering multi-platform. They try to write worms that they can, for example, go from Windows, they can propagate from Windows to Linux machines. Especially in most of Linux distributions or Unix distributions, we see many scripting codes that they try to do things in scripting, and that's a good kind of potential for worms uh, to detect vulnerabilities and to exploit vulnerabilities and to use them. Multi-vulnerability or multi-exploit. The term vulnerability that we use here in our course and in our book is somehow a synonym with exploit. So multi-vulnerability or multi-exploit, it means that they try to exploit different things. They don't only sit at one specific vulnerability, because of course that reduces the chance for propagation. And we talked about it. They check many things: web servers, web browsers, email, file sharing, and many other resources or platforms in order to find vulnerabilities. Ultra fast spreading. This is again another feature. They try to exploit ways in order to optimize the spread rate. The propagation rate that we just talked about in this curve, they try to optimize it. They try to make it, keep it as much as possible to get close to 100% infection. It means that they look at the different ways of or different vulnerabilities that they can use. Polymorphics or polymorphism, similar to what we saw in viruses, the polymorphism technique is also using worms to evade detection, to skip filters. There might be some filters or some signatures in the antivirus and anti-worm softwares that they try to, or maybe even a real-time analysis that they try to detect worm and viruses. They use polymorphism and metamorphism, again similar to viruses, in order to increase the chance or increase the time they have for propagation, again to maximize the number of infected machines and infected hosts. Transport vehicle, it means that since the infection rate of worms is very efficient or very kind of is high, worms are sometimes or often used as a vehicles to carry other malwares or other malicious activities. For example, there are some, we talk about denial of service attack or distributed denial of service attack. This is a very important type of attack. But some of the denial of service attacks, they use worm or some types of worms for just propagation phase. So they use worm as a vehicle to propagate them to different machines, and then they start doing the actual attack. So the worm itself is here just used as a vehicle, as a transportation mechanism for spreading other types of malicious activities. Okay, and this is something that I just mentioned about when I was talking about worms: zero-day vulnerabilities or exploits. It means that, of course, existing vulnerabilities or exploits can be used by our worms, but of course, if someone knows, or some software developers, operating system developers, kind of get to know some vulnerabilities, they of course try to fix it. They release some patches, and that's why we see all the time, for example, our Windows or our Linux or our Mac machine, they get updated and they apply some patches in order to fix some vulnerabilities. So worms can use existing vulnerabilities, but the ideal things for worm is to exploit an unknown or zero-day vulnerability. Zero-day vulnerability means that a vulnerability which is not being detected or not being discovered by anyone. So and this is the portion which needs a kind of expertise. Worm developers, hackers, they need to know details of computer systems and computer networks, and they find a vulnerability, they define or they develop a worm based on that vulnerability, and no one knows that vulnerability, and this gives them a higher time or higher chance to increase the propagation fade length in terms of time and increase the number of infected machines in terms of numbers. In 2015, something like about 54 zero-day vulnerabilities were discovered and exploited by worm, which means that they're active. Hackers are active, they find different vulnerabilities and they exploit them. I think that should be enough for today. Next lecture video, I'll be talking about APT, Advanced Persistent Threat, which is to some extent different with what we have talked. And then I guess next week we can finish the major malware we have named now. Thank you for making today's class. Please don't forget that, like, anytime you can email me if you have any question. And please don't forget to insert the attendance code at the test after the lecture video. And see you later. Have a good day. Bye-bye.